Alright guys, welcome back to Algos Made Simple. Have a little bit of a tricky linked list problem today. It kind of combines several elements of linked list, or several problems we do in linked list into one problem here. But if you have a good foundational linked list, it's not bad at all. Even if you don't, we're of course, like we do in this channel, we're going to make it as simple as possible and try to just spell it out to you where you really feel like, hey, if I can remember how to do X, Y, and Z, or if I remember to do X, Y, and Z, I can attack this problem if I get it. It may not, be the one I'm looking most forward to getting, but it's something I could knock out because I remember what we did in this video. So stick around, let's go through it and see what we can do here. It's Leetcode 143 Reorder List. You are given the head of a singly linked list. The list can be represented as list index 0, list index 1, ... list index n-1, list index n. Reorder the list to be on the following form: list index 0, list index n, list index 1, list index n-1, list index 2, list index n-2, ... You may not modify the values in the list nodes, only nodes themselves may be changed. So I'll let the interviewer know, okay, I understand I'm getting a regular singly linked list, and I want to reorder it in a way that the original first node, where it's in this order, the original first node, and that links to the original last node. The original last node links to the original second node. The original second node links to the original second to last node. The original second last node links to the original third node. The original third node links to the original third to last node. The original blah, 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 and this keeps going. But basically it's going back and forth. I want to take from the front, take from the back, take from the front, take from the back, take from the front, take from the back. So no issues there. Not too bad at all as far as what's being asked. I know I can't modify the values in the list node, so I can't just change the value property to equal what I need it to equal. I've got to actually change the .next property to link to the correct node that I'm utilizing. So I'm utilizing the nodes that they've given me. I just have to reorder them. So as you may have been able to tell what's going on from this right here, it's a lot easier to tell when you look at this example with actual numbers. So you have, okay, I'm taking the 1, taking the 4 from the back, taking the 2, taking the 3 from the back. All right, and then as the list gets longer, you can detect the pattern even easier. Taking the 1, taking the 5 from the back, taking the 2, taking the 4 from the back, taking the 3. So it's easy to see what's going on there. If this was a regular list or a regular array kind of thing, it would not be hard to do at all. You could just find the length and start working on some indexes, do a little loop or whatever, and take index 0, take index n-1, take index, index -1 or whatever kind of thing, index 1, index 2, index -1, -2, whatever kind of thing, and just keep going across here and pulling them out so there wasn't anything left, and put them in that order. That's no problem. That'd be easy. Unfortunately, with linked lists, they do not have indexes or indices or whatever you want to say. So what we have to do it in a different way here. We have to attack it a different way. Well, if you were to take this and say, okay, here's my first node, and then I'm going to run a while loop and do .next, and keep going until my node is null, then I could keep a previous and then pull that out and put it on there, and then I could do that for the next one. I could say .next up here, and then go .next till I get the 4, as long as I hadn't hit the previous. But it's a big mess. It's a slow algorithm if you did it that way, and I'm not even 100% sure if it can be fully done that way because I haven't coded it out that way, because the somewhat optimal solution is very, very easy kind of thing, or what I feel is a pretty optimal solution for it is very, very easy. So with that being said, one way you could look at doing it is, okay, what if I knew where my middle was at in this thing? So in this case, 3. Then I would know, okay, I'm taking from this list, then I want to take from over here, and then I want to take from over here, then I want to take from over here. If you knew the middle, all of a sudden you have kind of a pivot point to work around. But the problem is, and so you basically, on the game plan, where's the middle? And then beyond that, once we have the middle, we want to be able to treat like 2 separate lists. And how we would do that is, we'll take this middle node and we'll have the middle.next equal none, and that literally will separate these into 2 separate lists. So we'll have 2 separate lists at that point. So we're looking at, we had 1, 2, 3, 4, 5. So we had 1 links to 2, 2 links to 3, 3 links to 4, 4 links to 5. Okay, now we have 1 links to 2, 2 links to 3, and 3 doesn't link to anything, so 4 links to 5 is over here by itself. So now we could say, okay, I'm going to take the head, this 1, and then I'm going to take the head of the next list, this 4, and you're closer to what you need to do. But the problem is the head of this list now is still not what you need it to be. You need it to be this 5. So if you reversed this list, so if we said, okay, well, all right, I got one regular list and the other list needs to come in reverse order, so I'm going to reverse a linked list like I've done before. So I have the 5 and the 4. Then I can merge these by going, okay, I'll take the head. All right, then I'll take the head of this other list. Then I'll take the dot next to this list. Then I'll take the dot next to that list. And then I'll do the dot next to this list. And I'll take the dot next of the next list, which is null. And I'm done. So I have 1, 5, 2, 4, 3 like I want to have. 1, 5, 2, 4, 3 up here. So where's the middle? Treat like two separate lists. Reverse the second list. And then we're just merging the list. So if you can remember this in this problem, you can find your way around. Middle, reverse, merge. Middle, reverse, merge. Okay, and even up here, finding the middle, you know, in an even problem, it'll still work out. I'll show you how in the code here in a second, but you would have this 2 be your middle, and you'd separate the list into 1, 2, and 3, 4. But let's look at it with the code. The code, I think, on this one really clears it up a whole bunch. So we're going to say reorder list, and we have the head passing through. All right, and we said we wanted to find the middle. Well, how can you find the middle? You can use a variation of the tortoise and hare algorithm. So we'll have a slow pointer, and we'll have a fast pointer. The slow will be originally at head. The fast pointer will be at head.next. And then what we're going to do from there, so you have a slow at this 1, and you have a fast at this 2. We're going to say slow.next, so it'll move to the 2. We're going to say fast.next.next because it's fast. It'll move to the 4. We'll have slow move to the 3. This fast will move off the page. Once it's moved off the page, wherever that slow is at, that's our middle. So up here, slow, fast, slow.next, fast.next. The dot next is equal to null. The 2 is our middle. So what does that look like? We're going to say while fast and fast.next, so what it's linked to, while neither one of those are null. So you can just put it like that. We're going to say slow equals slow.next, so it's only bumping up 1, bumping to the next link. Fast equals fast.next.next. And when we're out of that loop, our slow pointer will be at the middle of this list. So then, like we said, okay, we want to have them treat as two separate lists. Well, one thing we need to know, and one thing to keep in mind, before you change a dot next in here or overwrite something on one of these linked lists, in these problems, it's normally a pretty good idea to go ahead and copy it because you're probably going to utilize it. So we're going to say second, as in second list, equals slow.next, because slow.next, so that 3.next will get us into this second list. So now we're over here at the 4 links to the 5, we're in this second list over here. That's fantastic. That's where we want to be. And then once we've copied it, we don't have to worry about it anymore. We can overwrite it. Slow.next, when we're treated as two separate lists, slow.next equals none. We just, with that one line of code, we just severed the connection between these two lists. Now you have one link into 2, 2 links to 3, 3 links to null, 4 links to 5 on its own. There's no link to 3, 2, or 1. They're two separate lists with that one line of code. So big piece of the code right there. Can't forget that. Then we're going to dive in here. We're going to say while second. So while we're in that second, while that second is not null, so we're in the second part of the list, we're reversing here. Let me put that up here so you know. We're reversing this reverse second list. We're reversing that second part, so that way the 5's first and the 4 is second. So when we pull the head, it'll be that last number like it's supposed to. So we're going to say from here, so if you reversed the linked list before, you know there's a lot of daggone saving variables and copying over stuff. So we're going to say temporary And that's going to be, the only thing we need to get from the second right now is second.next. So we have its .next property, which in this case, the 4 will be linked to the 5. Okay? Then we're going to take the second.next because we've copied it. We don't need it anymore. We can update it to what we want it to update. We're going to update it to the previous number. So when this 5 is in here, we want it to be linked to the 4 that we're working on right now. So we're going to have the previous, right? Well, we're going to come up here because we don't have a previous already and put a previous variable and equal to none. That way this 4 used to have a .next to 5, which is what's happening right here. Is what we're saving. Now it has a .next to null, has a .next to nothing. So now we've used this previous, now we can overwrite this previous. This previous is going to be overwritten to the number we're at right now because we want to have that previous be what the next number we work on is linked to, because we're linking them in reverse. So how do we get to the next number? Well, that's why we save this temporary variable. Second is now going to equal TMP, because if you did second.next, it's going to null now. So that's not what you want to do. You want to have what second.next was going to go to. So now when you come through here, and let's do this one real quick. Let's reverse this list, this small list real fast. So I'm coming down here. I've ended up in the middle right here, right? And we discussed how we did that. So we got second equals slow.next. So my second right now is equal to 4. Okay? The node 4. So we're saying while second, okay, it's not null, it's 4. And we're going to say temp equals second.next. Okay, so it equals the .next, which is 5. Now we can overwrite what 4 is linked to. So up here, 4 was linked to 5. Now 4 is going to be linked to nothing, to null. Okay, 4 is linked to null. So we're coming here, and so we're saying second.next equals previous, so that equals the null. And then we're going to say previous equals second. So what second is right now is going to be the new previous. It's going to be 4. Okay? Second is going to equal what second.next was, so 5. So when we go through here now, we got while second, which is 5. The temp equals second.next, null. Second.next is going to be equal to previous, so 4. And we have previous equals second, which right now the second is 5. The second equals TMP, null. So we're done at that point. We're going to come up here and we're going to be equal to null. It's going to kick us out. But that 5 is in play now as linking to 4. 5 links to 4. 4 does not link to 5. And 4 links to null. That's our new list right there. That's how it's in reversed. So that's how you reverse a linked list. No, not real big there. Nothing too hard to grasp right there. If you do a couple reverse linked lists, guys, and just work it out, it becomes very, very easy. Again, you just need to make sure you remember, hey, I'm got to save some information. I got to overwrite some information. I got to save some information. I got to overwrite some information. Here's save, overwrite. Save, overwrite right here. So you're save and overwrite, save, overwrite, save, overwrite. So with that being said, we've got it reversed. And what we ended up, we know we ended up here at null. So that's what we ended with. And our previous is the 5 that links to the 4. So then we're coming down here, and the only thing left to do now is to merge these lists, which should be easy now. We've got them the way they need to be. We know if we take the head of the first one and the head of the second one, if we have the head of the first one linked to the head of the second one, we're on the right path there with what we want to do. So we're going to say, okay, for this merger, second, because it's the second list and we have it equal to null right now, it really needs to be equal to the head of the second list, which is the previous. It's that 5. It's the last number we operated on and the last number in the original second linked list. So this is going to be 5, okay? So tracking with me there. We're going to have the first, of course, just be equal to the head. It's just what it was, no problem. And we're going to say, and for here you could say while first and second, but we're just going to say while second is not null. And the reason for that is because because the second will have either the same amount of numbers or less numbers in the first. So you don't have to worry about doing the first, but you can put it in there. Again, it does not matter, semantics kind of thing. So we're going to merge this list in, which again is going to take some overwriting, some saving, etc., etc. So the first thing we want to do, if you think about it, we know we're going to overwrite where this number right here goes to. So we're going to overwrite that this 1, instead of connecting to 2, connects to 5. But we want to remember this 2. We don't want to just discard it. So we know we're going to save that in a temporary variable. So we're going to have a temp1 equals first.next. So what first.next used to be. All right, and then same thing for this side. So we have a 5 and a 4 now. Imagine this is the 5 and this is the 4. That 5 links to 4. And what we're going to do is we're going to have it be linked to the 2 instead. So we're going to overwrite what it's linked to. But we don't want to lose out on that 4. We don't just want to lose it out in the ether here. So we're going to save that 4 to be utilized. So temp equals second.next. So that's that 4 right there. Now that we've done that, we're ready to rewrite these things. We're ready to make something happen here. So of course our first.next is going to be equal to second. Okay, and that's going to be, so our first right here, we'll keep track right here up top. Our first is 1. Okay, our 1 was linked to 2. It's now been overwritten to be what the second is, which the second is 5. So it's been overwritten to link to 5. Okay, our 5 was linking to 4. Okay, so this is what it looks like right now, and the 4 linking to null out there. So this is what our list looks like right now. 1 links to 5, 5 links to 4, 4 links to null. It's over with. But we're going to take that 5 and its dot next, so second dot next, and we're going to have it equal to temp1, which is the first dot next that we saved, which is the 2. So now the 5, instead of being linked to the 4, is linked to the 2, which that 2 right now still has its link to 3. So at that point, your 2 is still linked to 3, so you'd have something like that, 2 linked to 3, and that 3 is that 3 is the middle that we found. It's linked to null. So this is your list right now, 1, 5, 2, 3. We're close. We're not where we need to be. We're close. So then what we do is, this first and second, of course, have to be updated. The first is going to be temp1, so first is going to be that first.next, which that first.next that we had was this 2 that we saved, okay? And then second is going to be temp2, which is that 4 that we saved. So 4 and 2, okay? Now we're coming through here. Second's obviously not null. We're saying temp1 equals first.next. So that 3 is what that first.next is now. Temp2 equals second.next, which is null, okay? So we're coming down here. We're saying first.next equals second. Well, our second got set equal to that 4. So we're saying 4 right here. So first.next, which is that 2, used to be linked to 3. It's now linked to 4. Okay? And that 4 right here, which was linked to null, is now linked to temp1, which, was temp1 was, temp1 is up here. It's been first.next is 3. So it's now linked to 3. This 4 is now linked to 3. First is going to equal temp1, which is 3. And the second is going to be equal to temp2, which is null now. So we'll come through here, while second, it'll be null. So now our list is 1, 5, 2, 4, 3. So we're taking 1, taking 1, taking 1, taking 1, taking 1, just like we wanted to do here. So that's the entire problem, guys. So you have to really kind of, I'm going to try to get this on one page real quick for you. Okay, so you have to really think through this one and say, okay, I need the middle. So that's an algorithm in and of itself, is finding the middle. That's a little component of this thing. And you've worked through that. You've been able to figure out how to find the middle. So what we said was, you set the slow and you set the fast. So you set the fast equal to 1 over the slow. And while the fast is not null, or what it's linked to is not null, you just keep bumping the slow by 1 and the fast by 2. And once that fast equals null, what you have in the slow is going to be the middle. So then we want to save this start of the second list. So we're saving start of second list right here. So that's getting you to that 4. And now we can break these lists apart. Break these lists apart, or sever. I like sever the connection on lists. So that's where the 3 no longer connects to the 4 and 5. We have this previous equals none, which you maybe forget to do that until you get down here. But anyway, the previous equals none because the previous number we're going to link to anything to is going to be null. Because now it's time to reverse the second list. And when reversing, we know we want this dot next to be the previous number now. So if we go 4, 5, instead of the 4 being linked to the 5, we now want the 5 to be linked to the 4, aka the previous. So you get in here to your reverse second list. And let's just go through it just because we're here. So right now, our second's going to equal 4, okay? We got temp equals second dot next, 5, okay? So like I said, you want to save something and overwrite something. And you know you're not overwriting values here. So the only thing you can overwrite are these dot next. So now you got this dot next overwritten to null. So now 4 links to null. Previous equals second. So your previous is now equal to your second, which was 4. That's what we're working on. Your second is equal to your temp, so your second is equal to 5. You come up here while second, and then your second is 5 now, and you say temp equals second dot next. Well, that equals null. Your second dot next equals the previous, so we're rewriting. So 5 was linked to nothing. Now it's linked to 4. Okay, your previous is now 5, and your second is now null. So when you get up here, it says, okay, that's null, it's done. If this was a 6, you would just go through here and you end up linking the 6 to the 5. So, no worries there. You get out of there, and you remember your third thing is to merge. Okay, well, what am I going to merge? Obviously, the 2 lists. Well, my second list right now, the second variable that I have is null. So I need to have that second be equal to my previous, which again, your previous is going to be that 5 right there. So you have your second, you go to the previous, so the number before the null, which will give you the head of the second list. Your first equals head, so then you go while second, so your second is sitting there, the head of the second is the 5. And again, you can say first and second or just second, because second's going to be either the same size or smaller. So you're going to say, and let's go through this one more time just to try to make it as clear as possible. So we've got while second, and it's 5, right? So we're saying temp1 equals first dot next. So instead of being 1, or instead of the 1 dot next is linked to 2, the second dot next is linked to 4. So now we've got those saved. Now it's time to overwrite them. The first dot next we know we want overwritten to be the head of the second list, which is in this case is 5. The second dot next is now going to be linked. So this 5, so we're doing 2 for 1 on these follow throughs. So the 5 is getting linked in. And what the 5 needs to link to is happening here. So the 5 needs to be linked to second dot next, or I'm sorry, the 5 dot next needs to be linked to first dot next, which is the 2. So at this point, again, we have the 1, 5, 2. 1 links to 5, 5 links to 2. So then we say, okay, our first needs to be changed and updated. It is now the 2. So when we come through here again, it'll be 3. The second equals temp2. So our second is now the second number in the second list. And then we come up here and we say while second. Okay, while second is a 4, so we're ready to proceed. Temp1 equals 2 dot next, which is 3. Temp2 equals second dot next, which is null. The 4 is linked to nothing now. So then we say first dot next equals second, which is 4. So we come up here and we say, okay, that's linked to 4. So you see where we set our first equal to that 2. So that 2 is equal to 4 now. Or that 2 is linked to 4 now instead of being linked to 3. We go second dot next, so we take that 4, and instead of being linked to null, it is now linked to the 3. Okay, it's linked to temp1. Alright, and then you take that first, it's equal to temp1, which is 3. Temp2 is equal to null, and that causes us to exit, guys. And again, we have reordered that list the way we're supposed to. It's kind of a lot to think about, but you really just need to remember middle merge, or middle reverse merge, middle and sever, reverse merge, middle and sever, reverse and merge. If you remember that and remember how to do these components, you're golden. So just keep it to almost 3 separate problems. Okay, you're sitting there, can I just get the middle? Okay, I got the middle, sweet. What can I do now? Well, I'm going to take that middle, I'm going to sever the connection on the list, and now I can start working on that second list. And you know you want to reverse that second list. If you're fortunate enough to reverse it, fantastic. Now you've got a reversed list, a regular list that are not linked together. You need to merge it and make where they're linked. So that's where you come here and do your merger. So thanks for listening, guys. If you have a simpler way to explain this one, by all means, please put in the comments. Please reach out. Let me know, because I would love to hear it too. And I think the best thing on linked lists, I don't think they're super complex. I think it's just doing more and more, reversing them, merging them, whatever you got to do. The more you do of these, the more comfortable you get, and it's not rocket science by any means. It's something that you can really wrap your head around. It's just exposure, exposure, exposure. So thanks for watching, guys. We'll be back with another one shortly.